Hey guys, so just to show like why it doesn't matter where you put delta H just as long as you define it somewhere, let's just imagine this problem where we put delta H or the H0 as the ground so that we kept the 12 meters and 4 meters. Okay, what that changes, the only thing that changes is the potential energies. Right, so then I can come here and instead of 8, this is going to be a 12, and instead of a 0 here, oopsies. Instead of a 0, this now turns into 35, 10, 4. Right, so now I get some potential energy at the end, and it doesn't change anything else about our calculations, just that we start with a different potential energy and we end with some potential energy. So I'm just going to calculate 35, 10, 4 is 1400 joules, and then 35, 10, 12 is 4200. So if I were to change that, right, all that is changing is over here and there. This is going to be 1400. This turns into 4200. Right, so if I do this work, right, so I'm going to just box this here and say this was from the first way, right, with H equals 0 at 4 meters from ground. Now, if I were to do this calculation, right, we start with a 14 on that side. So, right, I'm going to move all of the terms that have numbers to the right side of the equation. So I'm starting with a 1400, and then I'm going to subtract 4200, and I'm going to add 11.22, and subtract the 640, right? So, and I actually have these signs wrong. This should be negative, and this also should be negative, which turns to a positive delta H. So, given the fact that I started with 14 over here, and then I just added all these, I get the same exact answer, and you can double check the work, but I get negative 2328.78 over there, and this is still going to be negative 70 delta x, so we still get the same delta x even though we have a different h equals 0, which should make sense because the h equals 0 is just arbitrary, right? Just as long as you have defined it and you're comparing everything else against that 0 point. So instead of having to have two potential energies, that's why we initially had the h at 4 meters, the H0 at 4 meters, so that we can just cancel out the potential energy. But in the end, the difference in potential energy from the beginning to the end is the same no matter where you put delta H. Okay, so I'll just box this and say we did this with 2 H equals 0 at ground, and we get the same exact answer. So I just wanted to show you why we utilize delta H0 where we do, because it makes our lives easier with one less term, or in previous problems you could potentially get 2 less terms.